A file seems simple. Steel, teeth, a handle. Yet before machines could make it, every tooth was cut individually. One craftsman, one chisel, one hammer blow at a time. If a single row drifted out of alignment, the file was useless. There was no correcting it. Before standardized parts, almost nothing could be built without first being filed into shape. Clock components, gun mechanisms, engine fittings, every surface that needed to be exactly the right size depended on this one tool. In the metalworking districts of Western Germany, valleys where ironworking had been practiced since the Middle Ages, small workshops supplied craftsmen across Europe. The geography made this region one of the most productive centres of metalwork in the German-speaking world. But here is what is remarkable. For most of the time, the file, one of the most critical tools in any metalworker's or woodworker's shop, was made entirely by hand. How? And why did it take so long for machines to replace the human hand?
Ja.
Daar moet die pad uit de clean up.
Oh man, daar is toen nog mee.
Kom maar op, pa.
Dat je nu.
The craftsman who cut file teeth was known as the file cutter. He learned by sitting beside a master for years, watching the angle of the chisel, listening to the rhythm of the hammer. Training his wrist to deliver a blow always the same weight, always the same speed. After that came years of travelling to other workshops, absorbing different methods, refining his eye before he could sit the examination for master craftsman. 3 files, 3 different forms, made to exacting standards. That was the test. The process began with the file smith. High carbon steel was heated until bright red. Then hammered into shape on the anvil, the correct profile, the correct length, the tang drawn out at one end to accept a handle. For larger files, 2 men worked the forge, a maker and a striker. The repeated blows refined the grain of the steel, compressing it into a structure capable of holding a sharp edge. Once shaped, the blank was annealed, heated in the forge, and allowed to cool very slowly, making the steel as soft as possible. Before a single tooth could be cut, every surface had to be perfectly flat. The file grinder sat astride a wooden seat called a horsen, bent over a revolving sandstone wheel running wet above a water trough, grinding every face of the blank until no blemish remained. Then came stripping, rubbing one blank against another until the surface was absolutely true. If the surface was not flat, the teeth would be uneven in depth, and uneven tooth tiers, it does not cut. Now came the work that defined the trade. The blank was laid on soft lead resting on the cutting anvil, a low block set in fresh horse manure to cushion the blows and prevent vibration travelling into the cutter's arms. His feet, in leather stirrups, held the blank still, chisel in one hand, hammer in the other. He began at the tip. One strike, one cut, precisely angled, precisely spaced. He cut the first pass, the upcut, across the full face from tip to tang, then turned the blank and cut a second pass at a crossing angle, the overcut, producing the double hatch pattern that gives the file its bite. If the spacing shifted by even a fraction of a millimetre, the file would cut unevenly. It would leave marks in the work. A craftsman would feel it immediately. A skilled file hewer struck between 80 and 220 blows per minute. At that pace, a good craftsman could finish up to 50 files in a single day. The regularity of the cut, the perfect parallel spacing of each groove, was not merely functional, it was the signature of a master. By the early 20th century, machine cutting had begun replacing hand cutters in larger factories. But in small workshops of Western Germany, hand cutting continued into the 1940s and 1950s. The knowledge already in the room had not yet been replaced. The cut file was still soft steel. Without hardening, the teeth were dull within minutes of first use. The file hewer packed the teeth with hardening powder to protect them from burning in the heat. Then the file went into the coke-fired hardening oven. At the right temperature, judged by colour and experience, not by instrument, the file was pulled from the oven and plunged into cold water. This quench transformed the steel, brittle at the teeth, slightly flexible at the tang where a second, gentler reheat reduced the risk of snapping. The file was then coated in oil to prevent rust. The master struck his mark above the tang. The handle was fitted. The work was complete. The file was not a prestigious object. It was a working tool, bought, used, worn down, replaced. But in the workshops where it was made, it stood for something precise. Quality in an invisible process produces quality in everything that follows. A badly made file meant a badly made clock, a badly made engine. The quality of a workshop's output was its only advertisement, and the quality of its output depended entirely on the consistency of hands that would never be seen by the buyer. File-cutting machines existed from the late 19th century, belt-driven, faster than any hand cutter, but they struggled with complex profiles, round, tapered, half-round files. Hand cutters remained essential for specialist work into the mid-20th century. The last hand file cutter in Germany finished around 1960, replaced not by a single invention, but by the economics of scale. The knowledge left with the last men who held it. Long before precision could be measured by instruments, it was produced by rhythm, by a craftsman who had made the same motion so many thousand times that his body had become the measuring tool. Every tool that shaped metal in the 19th century, every clock component, every blade, every machined surface, passed at some point across a file made by hand. These are the trades that built the precision world, quietly, without record. If preserving their history matters to you, tell us which hidden craft should we document next.